A plane is some set of points within the disk, and note that this disk is like the edge doesn't exist. It's the edge doesn't exist. You can just go up as close as you want, but you can't actually like touch the edge.
Okay, wait, hold on.
Yeah.
You guys slow down like a lot. This is where I start screaming at period 5. Can you like explain very carefully what is going on right now? What are you trying to do? What does this all mean?
Okay, so the idea behind the Beltrami-Klein model is to kind of create something that looked like Euclidean geometry, so even though it was actually hyperbolic geometry. So the way they accomplish that is by, instead of being able to do all your work on an infinite plane, you're sort of restricted to this one open circle. Open in that you can't have a point on the edge, but you can have it anywhere inside the circle. So.
I don't like that explanation. Wait, go back slide. Okay, first let's answer the quick question. What is hyperbolic geometry? So wait, what is hyperbolic geometry? It's not just one answer to this question, but I think there's one good answer right now. It's postulates 1 through 4, postulate 5 prime, and everything you can prove from that. Okay, so that's just like you would say Euclidean geometry is just the list of the postulates and the theorems that can be proven from those. Similar, that's hyperbolic geometry. So now, like, kind of a separate question is like, all right, well, what is it like, or something like that, right? What does it sort of look like, or what does it feel like, or how can I draw pictures of it, or something like that, right? Or another question you might ask is even all this type of crap like even possible? Because of course, if you believe that, this is where it gets complicated, if you believe that the fifth postulate is provable from the other 4, then what do you believe happens when given postulates 1 through 4 and postulate 5 prime? Just a straight up contradiction. Okay, that's a little bit subtle. Does everyone get that? If you think that the fifth postulate is provable from the other 4, which most people did, then you think that this is a contradiction. So how can you show that it is not a contradiction? You make a model, right? And so what we're trying to do is to present a world in which postulates 1 through 4 and 5 prime are all true. Okay, so how do you even like do that? We need to create some kind of example of how postulates 1 through 4 and 5 prime can be true all at the same time. Okay. So now, and there's even more to say. Okay. I guess I'll let you. Second try.
Okay. So a plane is so say this is the disk. A plane is like some set of points inside the disk. A point is just like something here, and a line is a chord without the endpoints. So like between these 2 points, let's see, like you can make a line or like extend it. But so that's the first postulate. You can also extend the lines because the edge doesn't really exist. You can't actually touch it. So you can always just extend it a tiny bit more because the postulate doesn't say you can make it as long as you want, just you can always make it longer.
Does this make any sense, guys, what he's talking about?
Stupid.
Really?
Yeah.
Wait.
Third postulate, we'll
Wait.
just ignore the circles are like, circles look really weird in the Beltrami-Klein model. Like,
Okay, but you're kind of missing the sort of explanation of what is really happening here. What do you mean by you have plane in quotes? What does that mean?
okay. Yeah, so yesterday we talked about like in the indefinable quantities, point line plane. So we said that sort of the geometry tells us how they interact. And the model is like describing every single possible interaction in a way. So for the purposes of the Beltrami-Klein model, the plane just is the interior of the disk. A point just is any point inside of the disk.
What kind of disk are we talking about?
A finite circular disk. Well, not
A finite open circular disk.
Okay, you're missing like a key thing here. How am I supposed to know about disks?
It's a thing that encloses the space.
Is that how it be?
Okay, wait. Yeah, but this is a Euclidean disk.
Yeah.
Okay, but that's actually kind of important. Wait, so this whole thing, okay, so this whole, I don't know, maybe you guys all get this, maybe I'm being overly pedantic, but what we're doing here, temporarily, is we're taking all of Euclidean geometry, and we're supposing that it's just like fine, okay? So just be okay with Euclidean geometry. We have points, we have lines, we have planes, we have all 5 postulates, we know all the theorems about Euclidean geometry. Okay, and now there's this new thing. This new thing is hyperbolic geometry. But recall that in any axiomatic system, at least in the modern perspective, we have undefined terms. So we have, in the original Euclidean axiom, we had undefined terms. How do we learn what those undefined terms mean? Well, by the axioms, right? The axioms tell me about them, and I grow to know more and more about them as I prove all the theorems. Okay, so now I have a new axiomatic system. And this new axiomatic system has axioms 1 through 4 and 5 prime. And this new axiomatic system also has undefined terms in it. And what are these undefined terms? They're still point, line, and plane. But they're going to mean something different now because the axioms are different. Okay, so again, I still don't know what they mean, right? I think that's the key here, right? Is that every axiomatic system has these undefined terms. So when we give a model, what we are doing when we give the model is we are giving definitions of the undefined terms. You with me?
Yeah.
Yeah, and so we are temporarily, when he puts plane in quotes like that, what he's saying is everywhere where you see the word plane as an undefined term in the hyperbolic geometry axioms, please interpret it this way. And by doing that, that's what this model is. Yeah, that's how you give a model. You give a model by giving precise answers to what's in the undefined terms. And the answer is whenever you see the word plane, interpret it as all the points inside a Euclidean circle. Right? So this is a Euclidean circle. And what is the word point supposed to mean when you see the word point in hyperbolic geometry as an undefined term? It's supposed to be a point inside this disk. And when you see line inside this in these undefined terms, then that's like a chord, but an endpointless chord of the circle. And so but it's a Euclidean circle. Right, so you're building, it's kind of weird, I think this is weird, you should find this weird too. We are building a model of hyperbolic geometry out of Euclidean geometry objects. Does that make sense? Did you guys understand this before 5 minutes ago also? Kind of? Yes, no, sort of? You get it now? Okay, so continue, because I think here's where it gets sort of interesting.
Okay, yeah, so the big question is, does this work? And when we can think about it is just look at all 5 postulates. So this picture is just like clear thing that postulate 5 prime works because like A, B, and C, D don't intersect line L. So you have 2 distinct lines through point P that are parallel to L.
No, we're using non-intersecting to mean parallel here.
Oh.
Okay. And Artemis already talked about postulate 1.
Wait, again, because I don't think it made sense before. What's postulate 1?
That you can make a line between any 2 points.
You can make a line between any 2 points. Why is that true? Class. Okay, yeah, kind of, I guess. Yeah, but it is. But what if someone questions this, whether it's possible to draw a line between any 2 points? Then what do you do? What do you say, Lydia?
You define points as being inside this disk, and so you can define so any line that's drawn between them can be extended into a chord, which is what you define lines as now. So you can't ever have something that contradicts with either of those definitions. You can't take the point that's outside.
Okay, I think I see what you're saying. All right, maybe I'll answer my own question. The reason why there is guaranteed to be exactly one line through these 2 points is that it is simply a theorem of Euclidean geometry that, given any 2 points in the interior of a circle, that there's exactly one chord through those 2 points. Do you see what we're doing? We're using the full knowledge of Euclidean geometry to prove, like, and so then take the next one, Artemis? Can you explain that second one again? Because the second one's also interesting.
The second one is that, like, for any line, you can extend it.
For any line segment.
For any line segment, yeah, it says line everywhere. But you can make that line longer and you can't make it an arbitrarily large like amount longer. So you can't just keep making it like 1 unit longer. You can make it slightly longer because it's open. So if you like zoom in on here a lot, it will look like this. And so you just make it like a little bit longer, and then you can just keep doing that. Because it's like asymptotically reaching here. It never does.
Yeah, right. This is why we this is why we recapped yesterday the sort of ambiguity present in postulate 2. Postulate 2 says that line may be extended indefinitely. Note that it doesn't talk about infinity. Who knows what that is? Can this line segment be extended indefinitely? Yeah, because we just go indefinitely and we get farther and farther and farther and farther and farther. Can I go farther? No. I can, man. I can always go farther because this is an open circle. And so I have an infinite amount of space to get as close to the boundary as I want, and I can never stop. I can always go even farther. Right, so are you guys seeing how this model satisfies axioms 1 through 4, and then yeah, that picture shows how it clearly violates the parallel postulate. Right.
Axiom 3 is really weird, like circles in Beltran
right. If you have your chapter 4 questions, I'll take them, and we will. What's this?
I will not be here on Monday.
Yeah. So I guess you'll just do this. Thank you. Yeah.
And you seem like extending, does that mean that you